So I record this to keep as a memory, So I play the music memory, then I listen to this. Then this is last lecture. Talk too much, then cannot finish another last one next week. Okay. So now we have. So example, we have gone through some example like this. Okay, in the notes you have to cut through whenever there is a loop. Okay, and then these are the cut. Three appear here, 2, 4 reaction forces. So how many add up together? And we make the decisions, conclusion, whether this is statically determinate or indeterminate. Okay. Can you see from there? Boleh nampak? Yeah. Can you see from there block or no? Hello, hello. Can you see? Yeah. Can you block by that whiteboard? No. So these are the things that we have gone through, and then just a refresh before I continue with the part that we want to look at, how to draw axial force diagram, shear force diagram, and also bending moment diagram for frames. So again, these are examples that we cut through, okay? And how many reaction forces, add them up together, how many parts you have. So this is how we make conclusion about whether it is statically determinate or indeterminate. Okay? Now, actually in frame, if you can also cut in these cases, yeah, separate them, cut at the members there, and then count how many internal forces appear here, 3, how many reaction forces. But for the case of frame, the important thing is you need to cut like this whenever, only when there is a closed loop that happens in the frame. In this case, you don't have to cut. Okay? If you cut and you don't cut, you are going to get the same conclusions. So in this case, because there is no closed loop, there is no 4 members or 3 members forming a closed loop, so you don't have to cut this, but you can cut as well if you want. Okay. Okay. So if you cut, then this will be the free body diagram. So if you count how many that you cut, 3 appear, how many reaction forces, then you can make conclusions. Yes. Okay. Number of equilibrium equation is each part, each free body diagram. If you cut this, then you have 2 parts, right? So each part you have 3 equilibrium equations. So if there are 2 parts, each part of this, yeah, you have each part of this, each part of this. Now this is being cut here. So you separate this into 2. So each one has 3. So 2 multiplied with 3, you have 6. So those are how we decide equilibrium equation. How many parts you have. Okay. Then you multiply each part with 3. Then you get total number of equilibrium equations. You have to know how many parts that you have draw, okay, when you want to do the checking of statical determinacy. So each part have 3. Each part you have 3 equilibrium equation for 2D problem. So if you multiply, then you get the total number of equilibrium equation that you should have. Okay. So now, example, the frame has specific situation where there is a closed loop that you never see in beam. So in this case, in order to check statical determinacy, you have to cut. You have to do the cutting. So where do we cut? We cut through here, and we have to cut through here. Or you can cut through here and then cut through here as well, or you cut here, or you cut here. Either way, you get the same result. The important thing, if you have to cut here, cut through this one and cut through this, because this is a closed loop. Okay. So in this case, this is how we cut. Okay. And when we cut here, you cut here, you cut here, you get 1 part, 2 parts, and 3 parts. So you get 3 here. 1, 2, 3. Okay. Then how many internal forces? This one cut, you have 3. Only 3 here, not 6. Okay, 3 here because these are same magnitude, direction different only. So 3, 3, 3, 3, 1, 2, 3, 4. Internal force 4 multiplied with 3 unknown. Reaction forces 1, 2, 3, 4, 5, 6. So 6 plus 12. You have 18 unknowns. Then reaction equilibrium equation, 1 part, 2 parts, 3 parts, so 9 equilibrium equations. So this is statically indeterminate. Okay. So here I give you example exercise, so you should be able to confirm that this is statically indeterminate and degree of statical indeterminacy. The I here is 12. Okay. And here I is 15. Okay. Please check this and make sure you can get this. So here you have to cut through here, cut through here. So this separate into 3 parts. Or you cut through here. If you cut through here also, you can cut through here as well. Then here you have to cut through here and cut through here to separate this into 3 parts. Or you cut here and cut here as well to separate this also into 3 parts. Then you count every time you cut 3 internal forces, how many cuts that you have made. Multiply with that, and then plus the reaction forces, how many unknowns, then compare with how many equilibrium equations. Okay. So class, this is what we have started last week and on statical determinacy, which is basically the same thing like what you have done for beam. We have to compare how many unknown forces and how many equilibrium equations. Okay. So please try out this one, and then to make sure that you can get I is equal to 12, you can also try to use the equations 3m plus r compare with 3j, and you should get the same conclusion. Use the equation 3m plus r compare with 3j. That we have one of the method also using that. Now we have 149 pages to go through. Now we finished 27 pages, so we finished at 10:29. We finished. Okay. 149 pages. So now we are 27 pages. Okay. You see here? Now, the main thing that I would like to go through with you tonight and finish off is about drawing of axial force, shear force, and bending moment diagrams for frames. Okay, for frames. Now, for beam, we have already gone through in the last 4 weeks, starting with analysis of beams, analysis of frames. Then we go to drawing of shear force diagram and bending moment diagram using cut section method and using direct integration method. So we draw shear force diagram, bending moment diagram. For beam, as I mentioned before, the axial force is normally 0, so we do not need to draw axial force diagram. But for frame, basically, we can follow the frame process to draw shear force diagram and bending moment diagram plus axial force diagram. Now, axial force in frame is not 0 anymore, and we have to draw other than these and these SFD, shear force diagram, bending moment diagram. Another one is axial force diagram. So axial force diagram shows you how the axial force changes along the members, okay, and in different members. So the next thing is we want to look at procedures and how to draw this. Basically, it is the same as what we have studied for beam. But for frame, because you have members inclined vertical, loading also inclined vertical or horizontal, so the calculation is more complex. Okay? Now, first thing that we have to go through is the directions of shear force, axial force, and bending moment. How are they defined? How are they defined? This is the first thing. Okay. Now, here I show you the diagram of a cut section. This one is the agent is outside there, then it become like this. So what happened? Here. It's something unexpected. Don't panic. Don't panic. And then this one panic.